Are the ways of the human heart a mystery to you? Do you think circulation is just something that happens to magazines? If so, then the Anatomically Correct World of Anatomy Program 5 is just right for you. We're going to take you on a tour of the cardiovascular system, through the veins, arteries, and even the heart. Like a red blood cell rocketing through the aorta, you'll zoom through the next half hour as we teach you everything you've ever wanted to know about the cardiovascular system.
Time for our pop quiz! How many chambers are in the human heart? Is it A, 3, B, 4, C, 5, D, 8? Stay tuned! We'll give you the answer following the show!
Your heart beats about 3 billion times during your life, but does it ever complain or ask for a vacation? No, it just keeps on ticking. Well, today we're going to find out how, and a bunch of other cool stuff about the heart. But what else would you expect from the standard DVD?
First up, circulation orientation, where we'll give you the 411 of the cardiovascular system. Then we'll head straight into what this system circulates, blood. And what pumps the blood? The heart, of course, which we'll describe in detail, followed by a description of all those blood vessels. And we'll wrap it up by looking at healthy hearts and heart problems. Now, our intro to the cardiovascular system, circulation orientation.
The cardiovascular system delivers oxygen and nutrients to cells and removes carbon dioxide and metabolic waste from cells. The cardiovascular system is made up of the heart and blood vessels.
The heart acts like a pump, pumping blood through the blood vessels. Blood vessels are like the plumbing that carries the blood freely through the body. There are more than 60,000 miles of blood vessels in your body, and the heart pumps blood through them all. There are two main types of blood vessels, arteries and veins. Basically, the arteries carry the oxygen-rich, nutrient-rich blood from the heart to all the cells in your body. Its mission accomplished, the now oxygen-poor, nutrient-poor blood goes back through the veins to the heart to pick up more supplies and start all over again. Isn't blood wonderful? Let's learn more about it.
When you take blood and you break it down, it's made up of two components. They are the plasma and the formed element.
The difference between the plasma and formed elements is that the formed elements are cells and cell bits, while plasma is mostly water with dissolved stuff like proteins in it. So the formed elements are living blood cells, full of life and born to party. They're the erythrocytes, or red blood cells, and the leukocytes, or white blood cells. There's also the thrombocytes, or the platelets.
Erythrocytes carry oxygen, the leukocytes fight infection, and the platelets, which are actually cell fragments, these little buggers help with blood clotting. That means they help you stop bleeding when you're cut. All these formed elements are suspended in the plasma. Plasma is a non-cellular, straw-colored, sticky fluid that's 90% water.
Blood's in charge of exchanging gases, hormones, nutrients, and waste between tissues. So blood is like a liquid cargo ship, carrying stuff to and taking stuff from tissues. Exciting, huh? Another thing that blood does is regulate body temperature. It does this by absorbing and distributing heat. But that's not all. The blood prevents infection with its white blood cells. And on top of all that, the blood also maintains proper fluid volume in the body.
Have you ever wondered why red blood cells are red? It's because they contain bright red protein molecules called hemoglobin. Hemoglobin is what actually transports oxygen and carbon dioxide through your body. A red blood cell makes a complete trip around the body about every 20 seconds. It will make about 250,000 round trips during its 4-month lifespan. Now that's some serious frequent flyer mileage.
Hey, blood isn't going anywhere without this guy. The big H, the pump-o-matic, the original Valentine, the pulse maker, the ticker.
The heart is a muscular organ that pumps blood throughout the body. Everyone knows that. But did you know that the heart weighs about a pound? That's pretty heavy.
The heart is located inside of the medial region of the thoracic cavity called the mediastinum. That's a hollow space in what you probably know as your chest. It is anterior to, or in front of, the vertebral column, or backbone. The heart is also posterior to, or behind, the sternum. The heart is laterally surrounded by the lungs. That means there's a lung on each side, and most of the heart is located just below and to the left of the center of the sternum, or the mid-sternal line.
What we call the base of the heart is actually the top, but it's called the base because it's the wider, flatter region. So, remember, when you're talking about the base of the heart, you're talking about the top. The great vessels, which we'll talk about later, branch directly out of the top of the heart. The bean-shaped portion of the heart in its lower left corner is called the apex of the heart. The apex rests on the diaphragm, a muscular structure we'll give you the details on later. The place where the apex of the heart contacts the chest wall is called the point of maximal intensity, which sounds like a bad summer blockbuster.
The point of maximal intensity, or PMI, is the part of your chest where you can directly feel your heartbeat. Try it. The PMI is between your 5th and 6th ribs, just below your left nipple. My heart is beating to the tune of La Bamba.
The heart itself is covered by a double-layered sac called the pericardium. The word pericardium means around the heart. Pretty clever, huh? The two layers of the pericardium are the fibrous and serosal layers.
The fibrous layer anchors the heart and bravely wards off infection.
The serosal layer keeps the outside of the heart lubricated by secreting a gooey substance called pericardial fluid. Yuck.
The actual heart wall is also multi-layered. There are 3 layers. These layers are known as the epicardium, the myocardium, and the endocardium.
The outermost layer is the epicardium. It helps reduce friction on the heart with even more pericardial fluid. The middle layer is the myocardium. Remember, M for middle, M for myocardium. Got it? The myocardium is a thick muscular layer filled with blood vessels. It's the part of the heart wall that actually contracts. And the innermost layer is the endocardium. It's a thin white line that melds right into the blood vessels that go through the heart. Endocardium, myocardium, epicardium, the layers of the heart.
But that's not all you need to know about your heart. Your heart is divided into 4 chambers, 2 on the top and 2 on the bottom, what I like to call the double duplex. These babies really get your blood pumping.
The top chambers are called the atrium. The left atrium receives oxygen-rich blood from the lungs. The right atrium receives oxygen-poor blood through 3 major blood vessels: the superior vena cava, the inferior vena cava, and the coronary sinus. All the blood in your body drains through these 3 blood vessels on its way back to the heart.
The 2 inferior or bottom chambers of the heart are called ventricles. You can think of them as the basement of the heart. It's the ventricle's job to pump blood out of the heart. It might help to remember that the ventricles are like vents because they let blood out of the heart. The walls of the ventricles are thicker and contract more forcefully than the walls of the atria because of their pump-intensive job. So the atria never pump blood out of the heart. The lazy good-for-nothings just receive it. But the ventricles work hard to pump blood. In fact, the wall of the left ventricle is the thickest wall in the heart because it has to pump the hardest. That's because the left ventricle has to pump the blood into an artery called the aorta, which we'll get to later. This pump begins to propel the blood to the entire rest of the body. This unbelievable pumping power gives the ventricles their nickname, the discharging chambers.
For now, let's review the path of blood in the heart.
The veins superior vena cava and inferior vena cava and coronary sinus drain oxygen-poor blood into the right atrium. The blood exits the right atrium and enters the right ventricle. Then the right ventricle pumps the blood into the pulmonary trunk. The pulmonary trunk branches off into the left and right pulmonary arteries, The pulmonary arteries take the blood into the lungs. The lungs fill the blood with oxygen and relieve it of carbon dioxide. Then they deposit the oxygen-rich blood into the pulmonary veins. The pulmonary veins carry the blood to the left atrium. The left atrium delivers blood to the left ventricle. The left ventricle pumps blood into the aorta. Then the aorta carries blood to a system of blood vessels throughout the entire body. Then the process repeats again and again until the end of time.
Ah, the sound of a beating heart. But do you know what makes that sound? It's the sound of the valves in your heart closing and opening. 4 very important valves that are coming up next.
Basically, heart valves are like hatches or trapdoors within the heart chambers. It's their job to make sure blood flows one way.
The valves do this by closing to prevent backflow. So when the blood flows from one chamber to another, valves open up and then close behind the blood so the blood doesn't flow back into the area it just left.
The heart has 4 valves, 2 atrioventricular or AV valves, and 2 semilunar or SL valves.
The 2 AV valves are located in between the atrial and ventricular chambers. They are the tricuspid AV valve and the bicuspid or mitral AV valve. Like we said, these valves help prevent backflow of blood into the atria.
The 2 other important heart valves are the 2 semilunar valves. These valves are made up of 3 flaps. They're called semilunar valves because they kind of look like half moons. They are the pulmonary semilunar valve and the aortic semilunar valve.
These valves are located at the bases of the large arteries coming out of the ventricles. The pulmonary semilunar valve prevents backflow of blood from the pulmonary trunk into the right ventricle. The aortic semilunar valve prevents backflow of blood from the aorta into the left ventricle.
And that's it. You can still tell me more about valves if you want. No, that's it. We're done with chambers and valves.
We've said it once before, and we'll say it again. Blood vessels make up the other major part of the cardiovascular system. There are 3 major vessel types in the body, and these babies have quite a job. All the blood that flows to and from the heart flows through these bad boys. Because they all have different jobs, vessel types differ in length, diameter, and thickness. The 3 different types of blood vessels are arteries, capillaries, and veins.
The arteries are vessels that transport blood away from the heart. The word artery also starts with the letter A, just like the word away.
A prime example of an artery is the aorta, the huge vessel that takes oxygen-rich blood from the left ventricle and transports it to the rest of the body. Capillaries form dense networks found in almost all tissues of the human body. These networks are called capillary beds, and boy, are they tiny. The diameter of a capillary is only 1/8,000 of a millimeter, just large enough to let red blood cells pass through single file.
Veins are another type of blood vessel, and they have an important job to do. Once the arteries deliver the blood to the capillaries, the oxygen and nutrients are delivered to the cells, leaving only impoverished blood. The veins carry the blood from the capillaries back to the heart. 65% of total blood volume is in the veins every minute of your life.
Veins below the diaphragm, that is, veins in the lower half of the body, are equipped with valves. These valves are similar to those found in the heart. Basically, their job is to make sure blood stays on track, happily flowing in one direction towards the heart. This is important in the veins of the lower body because the blood must flow against the force of gravity, so valves keep blood in line and on track.
Well, I don't know about you, but I, for one, don't want anything going wrong with my circulatory system. So let's see what you need to know about a healthy heart.
Hi, my name is Alex, and I'm a paramedic. Now, you can imagine how intense my life is, what with me being in the business of saving lives.
Alex, I think we're going to lose this one. But if you keep your heart healthy, you'll hopefully never have to be in that situation. So listen to your heart. Get this, when healthy, your heart makes these really neat sounds.
The sounds the heart makes are commonly referred to as love and dove, which, contrary to popular belief, is not the name of a popular 1920s vaudeville duo.
Hey there, Dove, why are you throwing that clock up and down?
Hey, because I want to see time fly down.
You broke it!
That's okay, love. It's your clock. Good night, folks.
Believe it or not, the sounds lub and dub really are technical terms, and they can be used to help us determine different heart functions. You see, the sounds have to do with valves. You remember valves. They're the little doors that prevent the backflow of blood.
The first sound, lub, is the sound of the AV valves closing after blood has moved from the right atrium to the right ventricle and the left atrium to the left ventricle. The term dub describes the second sound. This is the sound of the semilunar valves closing.
If you've ever heard anyone use the phrase heart murmur, they're usually describing an abnormal whooshing sound that occurs when heart valves aren't functioning properly. So remember, lub dub good, whoosh bad, yodeling not possible.
When the heart goes about its business, lubbing and dubbing all day long, it pumps out a certain volume of blood, which is measured in milliliters.
The volume of blood that the heart pumps out per beat is called the stroke volume. A healthy adult heart will have a stroke volume of 70 milliliters per beat. The total volume of blood expelled over 1 minute is called the cardiac output. To find the cardiac output, multiply the heart rate by the stroke volume. So let's find the cardiac output for a healthy human being. Like we said, average stroke volume is 70 milliliters per beat, and the average heart beats 75 times per minute. So multiply those two together to find the cardiac output. That's 70 milliliters times 75 beats per minute. So the average cardiac output for a healthy human is 5,250 milliliters per minute.
That's the average. Of course, during exercise or intense moments like saving lives, cardiac output will increase so that the body gets more oxygen.
You see, blood pressure is the force exerted on a vessel by the blood inside of it. Differences in pressure within the blood vessels are what drive the blood throughout the body.
When we measure blood pressure, we express it in terms of millimeters of mercury. You know, the poison stuff that's inside thermometers.
120 mmHg is the average blood pressure in healthy humans. So if someone has a blood pressure of 120 mmHg, the mm stands for millimeters, and the Hg is the symbol for mercury. So a blood pressure of 120 mmHg is equal to the pressure exerted by a column of mercury 120 millimeters high. The pressure on the vessel walls is equal to the pressure exerted by that amount of mercury. This may seem strange, measuring blood pressure in terms of a deadly substance, but that's how the doctors do it, so it must be right.
Also related to pressure is the arterial pulse.
You can feel your arterial pulse when you touch your lower arm proximal to or above your palm, in the carotid artery on your neck, and a number of other places on the body.
The arterial pulse is created by surges of pressure in the arteries created by the heartbeat. Blood pressure can be measured by using an instrument called a sphygmomanometer, or blood pressure cuff. I actually call it the arm strangler.
Oh, do. And then, of course, there's the sounds of Korotkov. You can't discuss blood pressure without mentioning the beautiful, beautiful sounds of Korotkov.
My chest is alive with the sound of Korotkov.
Now, before we discuss the sounds of Korotkov, it's important for you to remember what happens in the heart. Ventricles are contracting, pumping blood into arteries and putting pressure on them. When the ventricles contract, this is called ventricular systole. This creates the systolic blood pressure. Now, just after the ventricles contract, when they're relaxed, this is called ventricular diastole. This creates diastolic blood pressure.
When we first hear the sounds of Korotkov, the ventricles are contracting and the left ventricle is creating a lot of pressure in the aorta. This is called systolic pressure. Systolic pressure is normally measured at around 120 millimeters mercury. When the sounds of Korotkov disappear, there's less pressure in the aorta because the left ventricle is relaxing. This is known as diastolic pressure. Diastolic pressure is normally measured at around 80 millimeters mercury.
Now, like any high-performance engine, your heart can run into some mechanical problems. There are 5 disorders we'll cover: angina, heart attacks, abnormal heart rates, hypertension, and atherosclerosis.
Remember the myocardium? That's the middle layer of the heart. Now, if you remember the myocardium, you probably recall that the myocardium is really thick. In fact, it's so thick that blood has a hard time traveling through it to nourish the heart tissue itself.
So the heart has its own circulatory system. This involves blood vessels that bring blood to and drain blood from the heart tissue itself. So coronary arteries bring blood to the tissue of the heart, and coronary veins drain blood from that tissue. They provide the functional blood supply for the heart. But unfortunately, most diseases related to the heart impact this coronary circulatory system.
An example of a disease that affects the circulatory system inside the heart is angina pectoris. Angina pectoris is often called choked chest, which suggests that it's not very pleasant. Choked chest can result from spasms that block the coronary arteries and cut off blood supply to the myocardium. This causes intense chest pain and pressure.
Another example of a serious heart disorder that affects the coronary circulatory system is the myocardial infarction. Myocardial infarction is just a fancy word for heart attack.
Myocardial infarction, or heart attack, is caused by the death of cardiac muscle cells. This is usually the result of prolonged blockage in the vessels of the coronary circulatory system. This leads to inadequate blood flow and oxygen delivery to cardiac muscles. Eventually, if the cardiac muscles are deprived of oxygen for long enough, the cardiac muscle tissue is damaged. This damaged muscle is replaced with scar tissue that impedes the pumping of blood.
Myocardial infarction. It isn't pretty. And you can bet that there are some other heart diseases and disorders out there.
Alex, I need your help, please.
Cool your jets, I'm coming. Just to pointlessly frighten you, here are a few examples of some minor and major heart disorders.
There are certain conditions that deal with blood being pumped in and out of the heart that are a little less serious, but still nothing to scoff at. These conditions are known as tachycardia and bradycardia.
People with tachycardia suffer from heart rates that are far above normal, usually greater than 100 beats a minute. If tachycardia persists for a long period of time, the heart will beat erratically and eventually stop functioning. On the other side of the coin, people with bradycardia have heart rates that are abnormally slow, usually under 60 beats a minute.
But don't get paranoid about the beating of your heart and think you have tachycardia if your heart's beating fast. You see, during exercise, the heart rate always increases to give the body, especially the skeletal muscles, more oxygen. So the faster you walk, jump, wrestle, or run, the faster your heart's going to beat.
Hypertension is another name for sustained high blood pressure. People with hypertension have a systolic pressure higher than 140 millimeters of mercury and a diastolic pressure above 90 millimeters mercury. This increase in pressure can be caused by a number of factors, but the end result is always the same, an increase in resistance to blood flow in vessels. When the pressure gets higher, it's harder for blood to flow. It's like trying to channel a fire hose into a garden hose.
Everyone has some degree of atherosclerosis. It usually begins with the accumulation of fat along the inner walls of the arteries. When this happens, the buildup is called plaque. Over time, this plaque hardens, which stiffens and narrows the arteries. This causes a rise in blood pressure, which further damages the artery walls. The heart has to work harder to pump the blood through the narrowed and hardened arteries. The body responds to the damaged artery walls the way it would with any injury. It forms blood clots. When there's a lot of plaque, then the blood clots form faster than they're dissolved. This isn't a big problem in large arteries, but if the clot breaks off, it will travel through the body until it gets stuck in an artery that's too small for it. The nearby tissue can't get any nutrients. That can spell big trouble. A large clot stuck in the heart causes a heart attack. A large clot stuck in the brain causes a stroke.
So take care of your heart so it can take care of you. Now let's take a look back at some of the stuff we've seen today.
The cardiovascular system pumps blood throughout the body. Blood contains red blood cells, white blood cells, and platelets. The cardiovascular system contains the heart and the blood vessels. The heart wall has 3 layers: the epicardium, the myocardium, and the endocardium. The heart has 4 chambers. The top 2 are atria, the bottom 2 are ventricles. There are 3 types of blood vessels: arteries, which transport fresh blood through the body; capillaries, which deliver the blood to all the cells; and veins, which transport the blood back to the heart. Some of the problems the circulatory system can suffer from include hypertension, atherosclerosis, and heart disease.
Well, that's all the time we have for today. I'm really glad you stuck around. That's from the heart. Etched in stone.
Here goes. The cardiovascular system delivers pizza to cells in 30 minutes or less. Wait a second. That's not right. New stone. The cardiovascular system delivers oxygen and nutrients to cells. There. That's much better.
Etched in stone.
We asked, how many chambers are in the human heart? As you may have guessed, the answer is B, 4. The human heart has 4 chambers. The left ventricle, the right ventricle, the left atrium, and the right atrium.
This is PBS. To order this or any other Standard Deviant School products, call 1-800-238-9669 or visit www.standarddeviants.org.